I just taught you Omihida's law, which is V equals IR. By the way, Omihida's not a real scientist. He's just a dude that goes to Drexel. I just taught you Ohm's law, and rearranging Ohm's law using algebra, you get the electromotive force minus the IR equals 0. Now 0 can represent the potential difference between the two ends of a battery. So you have the high end of the battery and the low end of the battery. And you can describe these as VB and VA. Now, since the low end of the battery is 0, I can put VA on this side, but because I put it as a variable, I need VA on this side as well. So VA plus the electromotive force minus IR equals VA. And this is known as Kirkhoffs loop rule. Some crazy Russian guy. So
German.
German?
Yeah.
I'm not very good with nationalities. I'm just a physics major. So using this Kirkhoffs loop rule, you can solve for pretty complex equations. So let's start at the dot. And before I explain anything else about how to use this equation, you need to realize that when you go along a circuit using his rule, if you run into the negative terminal of any component to the positive terminal in that area, so if I go that way and I go negative to positive, you add that component, and I'll elaborate on that later. And plus to minus, the opposite is subtract. So basically, you have to look at a circuit and choose the battery that you will think will determine the flow of that circuit. Now, I have a 6-volt battery here, I have a 3-volt battery here, and I have a a 2729-volt battery right here. Now, I think that 2000 volts is a lot higher than these two. I think this will dictate the flow of this circuit. So, starting at the low end, which is VA, I go minus to plus on a 2729-volt battery. Minus to plus is add, so it's positive, visible positive, 2729 volts. Now, going this way, the current has only one way to go. So it is I1, right? I1 along this, I1 along this, until I get down to here, and we'll split off into two branches, which I'll get to later. So I go along here, and I run into another battery. Minus to plus. I add that battery, 3 volts. So I add another 3 volts to Storm Robotics battery. And I keep going, and I run into a 6 ohm resistor. Now you say, resistors don't have any polarity. They can go either way in a circuit, left, right, up, down, whatever. I follow the positive end of this battery around, because that is the master battery, to dictate the orientation of each resistor. This battery I cannot dictate because it has a high and a low end, but resistor, I follow the positive around. This is the positive end of the resistor. This is the negative end of the resistor. Positive to negative, I subtract. Now remember, IR is different than the V's. So I have to subtract 6 ohms times I1. 6 ohms times I1, right? Now, I keep continuing down this circuit and I run into a problem. The current has 2 places to go. Whether it'll split evenly or not determines on which components you have in here. So I don't know if they'll split evenly, but they will split off into 2 things that will add up to I1 when it gets back later. Kind of if a river splits in 2 parts and comes back together, it will equal the same river. So I2 and I3 is what I will call these. Basically what I just explained is called the junction rule, that I1 equals the sum of I2 plus I3. So continuing along this loop, I'll choose this path for my first part of the equation. I go plus to minus on this battery. You have to subtract the battery, 6 volts. I run into a 9 ohm resistor, plus minus. Now, instead of writing minus 9I1, I write minus 9 ohms I2 because this flow is different than this flow because it's split up. Now, since VA, our low end, is 0, I write 0. That's my first equation for this loop. Now going around on the second loop, I have to start here again. Again, 27, 29 volts, 3 volts, minus 6I1 over here. It's all the same until I get down here and I make this turn when I have to subtract 7 ohms times I3, and then I come back to 0. Now, in these equations, we have two unknowns, I2 and I3. Using the junction rule that I just explained, I1 equals I2 plus I3, you can use algebra to solve for your two unknowns to get the answer. Now that will take a long time, and I'm sure your physics students can do that. So I'll leave that up to you, and you can turn it in to me for extra credit. And that is this lesson.